Hello students, welcome to Physical Science Digital Classes Mahabubabad. Myself Narendrababu PGT Chemistry, TSMS Mahabubabad. Today, Human Eye and Colorful World, Class 10, Part 12. In this session, we are going to discuss about atmospheric refraction. What is atmospheric refraction? In the atmosphere, we have air everywhere. But all the air in the atmosphere is not at the same temperature. In the atmosphere, we have air everywhere, but all the air in the atmosphere is not at the same temperature. Some of the air layers of the atmosphere are cold, whereas other air layers of the atmosphere are comparatively warm or hotter. The cooler air layers of the atmosphere behave as optically denser medium, and the warmer air layers behave as optically rarer medium for the light rays. The cooler air layers of the atmosphere behave as optically denser medium, and the warmer air layers behave as optically rarer medium for the light rays. So, in the same atmosphere, we have air layers having different optical densities. When light rays pass through the atmosphere having air layers of different optical densities, then refraction of light takes place. When there are different densities in layers, when light passing through these layers, then only the refraction takes place. Why? Because the densities of the layers are different. So when light rays, they move from one layer to the another layer having the difference in their densities, then refraction of light takes place. So here also, when light rays pass through the atmosphere having air layers of different optical densities, then refraction of light takes place. The refraction of light caused by the Earth's atmosphere is called atmospheric refraction. The refraction of light caused by Earth's atmosphere, that means having air layers of varying optical densities, that is called atmospheric refraction. Note, under normal circumstances, the air in the upper atmosphere is optically rarer, and as we come down, the air in the lower atmosphere is optically denser. Under normal circumstances, the air in the upper atmosphere is optically rarer, and as we come down, the air in the lower atmosphere is optically denser. Some of the optical phenomena in nature which occur due to the atmospheric refraction of light. First one, twinkling of stars. When the light coming from a star enters the Earth's atmosphere, it undergoes refraction due to the varying optical densities of air at various altitudes. When light coming from a star enters the Earth atmosphere, it undergoes refraction due to the varying optical densities of air at various altitudes. The atmosphere is continuously changing. The continuously changing atmosphere refracts the light from the stars by different amounts from one moment to the next. The continuously changing atmosphere refracts the light from the stars by different amounts from one moment to the next. Let us see here. If you observe this, so there are different refractions takes place. That means different times here the refraction takes place. So when light coming from the stars, and once it enters into the atmosphere, Earth's atmosphere, then refraction takes place at different places where there is change or where there is a difference in the densities of the layers, then the refraction of light takes place. The star light reaching our eyes increases and decreases continuously due to atmospheric refraction, and the stars appear to twinkle at night. Next, second one, stars seem higher than they actually are. Due to atmospheric refraction, the stars seem to be higher in the sky than they actually are. If you see this diagram, In this is the actual position of the star, and this is the star we are able to see. That means star seems higher than the actual. So light from a star is refracted or bent as it leaves space, means from vacuum, and enters the Earth's atmosphere. Light from star is refracted as it leaves space and enters the Earth atmosphere. When light leaves space and when it enters the Earth atmosphere, so the light which is coming from the star, that bends. So like this, let us see how it bends. So the light that is when it is enter into the atmosphere, it bends. Actually, the position of the star is this, but when it is reaching us, because of the atmospheric refraction, it bends. But the observer thinks that the light is coming from the star from this position. So the observer used to think that the star is present at this position. That means the star seems higher than they actually are. This is the actual position, but this is the higher than the star. So actual position. At higher up in the sky is rarer, but that near the Earth's surface is denser. Higher up in the sky is rarer, but near the Earth's surface is denser. So as the light from a star comes down, the dense air bends the light more. Due to this refraction of star's light, the stars appears to bend at higher position. Third one, advanced sunrise and delayed sunset. If you see, we can see the sun about 2 minutes before the actual sunrise and 2 minutes after the actual sunset because of atmospheric refraction. We can see the sun about 2 minutes before the actual sunrise and 2 minutes after the actual sunset because of atmospheric refraction. The actual sunrise takes place when the sun is just above the horizon. The actual sunrise takes place when the sun is just above the horizon. See here, when the sun is slightly below the horizon, actually the real position of the sun is here. And this is the sunrise time and this is the sunset time. Let us see for the sunrise time. So when the sun is slightly below the horizon, this is the horizon line, and below the horizon, sun is below this horizon. So then sun's light coming from the less dense air to more dense air. The sunlight is coming from the less dense air to the more dense air and is refracted downwards. When it enters from the low denser air to the higher denser air or more dense air, and it refracts downwards. It refracts downwards as it passes through the atmosphere. If you see this is refracting downward here. It refracts downward as it passes through the atmosphere. When the sun is slightly below the horizon, then sun's light coming from the less dense air to the more dense air, it refracts downward. It refracts the downwards as it passes through the atmosphere. Because of this atmospheric refraction, the sun appears to be raised above the horizon when actually it is slightly below the horizon. Actually, so the light is bending like this, bending downwards. But because of this reason, the sun is below the horizon, but the observer thinks that the light rays are coming from this position. So that means the observer thinks that 2 minutes before the sunrise has taken place. This is for the sun rising. And as usual for the sunset. It is also due to the atmospheric refraction that we can still see the sun for about 2 minutes even after the sun has set below horizon. It is also due to atmospheric refraction that we can still see the sun for about 2 minutes even after the sun has set below horizon. This is the sunset. Actually, sunset has taken place below the horizon. But what is happening? The suns are coming from here and it bends downwards. But the observer thinks that the light rays are coming from this position. From this position, the light rays are coming. So that's why after sun setting 2 minutes also, so the observer thinks that the sun setting not taken place. Still the sun is above the horizon. He thinks like that. This is advanced sunrise and delayed sunset. Thank you. Thank you for watching this video.